Variability or spread is a single number that is used to describe the spread of a set of data. One measure of variability is the mean absolute deviation, or MAD. All right. So the MAD is the, hang on. Okay. So yesterday we kind of did median of median, right? Today we're working with mean. Okay. So MAD is the mean of the distances between the data values and the mean of the data set. So I'm going to find the mean, and then I'm going to find the distances between them. Now that doesn't make any sense to you yet, so so step one. First, I find the mean of the data set. That's the first thing I do. So I find the mean or the average. Okay? So mean, you add and divide. You add and divide for the mean. Okay? So let's look at this data set. Let's put this in order. Well, you don't necessarily need to put it in order for the mean, but we do need to add these. So get out your calculator. Okay, put in 95 plus 90 plus 70 plus 100 plus 65 plus 85 plus 80 plus 95 plus 100 plus 50. Okay, put an equal sign and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divide by 10. What do you get? 83. So if that was all your test scores, our average would be 83. Is there an outlier there?
Yes.
What?
50.
50, right? 50 is pretty low. Okay. All right, now you're going to find the distance. Each number is away from the mean that you calculated in step 1. All right? So, all you're doing is subtracting. So you can go ahead and use your calculator on this. I'm going to say 95 minus 83. I'm going to subtract the mean that I found. So what's 95 minus 83? 12. Okay. Then do 90 minus 83. And what do I get?
7.
Okay. And it's not necessarily subtract. It's just distance. So 83 minus 70 is what? 13. Okay, 100 minus 83 is 17. Okay, 83 minus 65 is 85 minus 83 is 80. The distance between 83 and 80. The distance between 95 and 83. And the distance between 183. And the distance between 50 and 83. Okay. Now, I have to take those distances and find the mean of them. So now I'm going to add all of these up. So just write this down for me so you know what it is. And then I will let you do it with your calculator. But first we're going to write them down. 12. So I'm doing these ones. Okay. So 12 plus 7 plus 13 plus 17 plus 18 plus 2 plus 3 plus 12 plus 17 plus 33. Okay, and I add and then divide, and then I'm going to take that number and I'm going to divide it by 10 because I have 10 numbers. Okay, so I'm going to find the mean of the distances. Okay, now go ahead and use your calculator. Let's put in 12 plus 7 plus 13 plus 17 plus 18 plus 2 plus 3 plus 12 plus 17 plus 33. What do I get?
134.
So I get 134 over 10. So divide 134 by 10, and what do you get?
13.4.
13.4. That is my mean absolute deviation. Okay, so I'm finding the mean, finding the distances between the mean, and then finding the mean of those distances. So not hard, just a lot of works, a lot of steps to remember. All right, the reason why we use mean absolute deviation is it's just a more precise way to find a mean, okay? Because you might have, so if you look here at team A and team B, if I added all those together and then I divided, I would have the same mean, I think. Maybe not. Two data sets may have the same mean, but look very different when graphed. So we're going to find a more precise way. So this is the number of magazine subscriptions sold by two teams. Okay. The mean number is 4, but do those numbers look very different? Yes, so we're going to find a more precise. Okay. So I'm going to find the means of the distance for each data set. Okay, so if it's 4, then I need to find how many away from 4, because the mean is 4. So what is the difference between 3 and 4? Okay, 1. What's the difference between 4 and 4? 0. 5 and 4? 1. And 5 and 4? 1. Okay, what about 0 and 4? 4. What about 1 and 4? What about 4 and 4?
0.
7 and 4?
3.
And 8 and 4.
4.
Okay, now I'm going to take these down here. I'm going to say 1 plus 1 plus 0 plus 1 plus 1. What's 1 plus 1 plus 1 plus 1? 4. Okay. Then can you take your calculator and put 4 in and say what's 4 divided by 5? Because I have 5 numbers there. What's 4 divided by 5? 0.8. Okay, now team B, I'm going to put in my distance numbers. 4, 3, 0, 3, 4. And that's divided by 5 because I have 5 numbers. So what's 4 plus 3 plus 3 plus 4? What is it? 14. No, it's not.
7 plus 7 is 14.
Oh, okay. Never mind. I was doing it another way. Okay, 14 divided by 5. So put 14 in. What's 14 divided by 5? 2.8. Okay. So the mean, if I just do the first numbers, is 4 for both. But if I do the more precise mean, the mean absolute deviation, is it different? Yes, it is. It's just showing a way to find the distance. So this tells me the mean of the ages is 10. So please box that. The mean of the ages is 10. It tells me what the mean is already. So now I want to find the distance between the mean and the number. So what's the difference between 10 and 8? 2. So I know this 1 is 2, this one is 2, this one is 2, and this one is 2 because there's 4 of them. What is the difference between 10 and 9? 1. What's the difference between 10 and 10? So these are all 0 because there's 3 of them. What's the difference between 12 and 10? 2. There's 3 of those. And what's the difference between 13 and 10? Now I'm going to add all these in, okay, even the zeros. So I'm going to say 2 plus 2 plus 2 plus 2 plus 1 plus 3 zeros plus 3 more 2's plus 3. So go ahead and quickly calculate that. I mean, that's easy. You can kind of do that in your head. 2 times 4 is 8, 9, 10, 11, 12, 13, 14, 15, 18. Okay, so 18. Now, how many do I have total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 18 divided by 12 is what? 1.5. So the mean absolute deviation of the data is 1.5 years. So if they give you the means on these, this isn't too hard. Okay. All right, so find the mean absolute deviation for both data sets. Explain which data set is more spread out. So I want to know which one is more spread out. So I have to find the distance between the mean. This tells me my mean is what? 7. What's the difference between 5 and 7? 2. What's the difference between 6 and 7? 6 and 7? 8 and 7? 10 and 7? 3. And how many numbers then do I have? 5. So what's 2 plus 1 plus 1 plus 1 plus 3? 8. Okay, put 8 divided by 5, and what do you get? What? 1.6. Okay. All right, let's do the same thing for this one. This mean is also 7. Okay. So, what's the difference between 7 and 1? 6. What's the difference between 3 and 7? What's the difference between 7 and 7? What's the difference between 11 and 7? And what's the difference between 13 and 7?
6.
Okay, and how many numbers do I have? 5. So add those together. That's easy. That's 6 plus 4, and 6 plus 4 is? 20. And 20 divided by 5 is what? 4. Okay, so, we didn't write this one down. 1.6. The data set of Laura, is it Laura's? Laura's laps is more spread out because the mean deviation is 4. So hers is more spread out. So for each dot, and it tells me my mean is what? 7. So now I want to know the distance between 7 and, so this number is 4. So what's the distance between 7 and 4? 3, and I have one of those. What's the difference between 5 and 7? 2. And I have 4 of those. What's the difference between 6 and 7? 1, and I have one of those. What's the difference between 9 and 7?
2.
I have one of those. 10 and 7?
3.
And I have 2 of those. And 11 and 7? 4. So now I have to add all those up. So add 3 plus 2 plus 2 plus 2 plus 2 plus 1 plus 2 plus 3 plus 3 plus 4. What do you get? I need answers.
24.
Okay, and then how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's 24 divided by 10? 2.4. All right, so what's my mean? 29. So I have to find the distance between 29 and 26. What do I get? Now each dot needs to be 3. We got to count the dots. 27 and 29 is 2. 32 and 29 is 3. 33 and 29 is 4. 35 and 29 is? 6. So now I have to add all those up. So that's 9, 10, 11, 12, 13, 16, 26. So 26. Now I need to count each dot. So 1, 2, 3, 4, 5, 6, 7, 8. Right? I had some of you counting each number. There was 1, 2, 3, 4, 5 numbers used. That's not what we're counting. We're counting the dots. Okay? We're counting these numbers. Okay, so what's 26 divided by 8? 3.25, right? Okay, how many of you got 3.25? Awesome, nice job. Okay, this tells me my mean is 11, so I want to know the distance between each number and 11, so I'm going to write it underneath it. What's the distance between 10 and 11? 12 and 11. 13 and 11. 18 and 11. 10 and 11. 8 and 11. 7 and 11. 6 and 11. 16 and 11. 14 and 11. 8 and 11. 10 and 11. Then I'm going to add all those up. So 1 plus 1 plus 2 plus 7 plus 1 plus 3 plus 4 plus 5 plus 5 plus 3 plus 3 plus 1. And I get? 36. And how many numbers do I have total?
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or January to December is 12 months. What's 36 divided by 12?
3.
3. How many of you got 3? Did anybody not get 3? Nice job.